Okay guys, today we're starting Unit 6. Unit 6 is called Describing Data, it's basically a statistics unit. And a lot of it is actually review. So today's notes, I'm going to be going through some of it kind of quickly because you guys probably already know it pretty well. And some of it I'll go through a little more slowly if it's newer. Alright, so in 6th and 7th grade, you learned how to calculate measures of central tendency, mean, median, and mode, as well as measures of spread or variation, range, and IQR. In this unit, we're going to use measures of central tendency and spread, along with other statistical concepts to describe data distributions. Before we review measures of central tendency and spread, it's important to understand the types of data we'll be using. So we're going to look at a couple different classifications of data. So one of those is called univariate data, and basically think about the prefix there, uni means one, so this is involving just a single variable, which is where the word variate comes from, so one variable. And then there's also bivariate data, which involves two variables, so the prefix bi means two. Alright, and univariate data does not deal with causes and relationships because there's only one variable, but bivariate data is going to deal with causes and relationships. With univariate data, our purpose is to describe data, and with bivariate data, our purpose is to explain data. So types of data calculations for univariate data would be mean, median, mode, range, mean absolute deviation, quartiles, bar graphs, histograms, box plots, dot plots. Those are all things that you guys have seen before. Some calculations we would use for bivariate data would be correlations, comparisons, relationships, cause and effects, and independent and dependent variables. Get rid of that. Those are going to be newer things. We haven't really worked too much with bivariate data yet. Some examples of univariate data, and again this is what we're more familiar with working with, would be like a data set of travel time, minutes. An example question would be, how many of the students in the freshman class are female? For bivariate data, again, remember this is dealing with like relationships between variables. An example would be an ice cream shop keeps track of how much ice cream they sell versus the temperature on that day. So they're comparing the relationship between the amount of ice cream they sell and the temperature on a given day and seeing, does the temperature affect how much ice cream they sell? An example question would be, is there a relationship between the number of females in computer programming and their scores in mathematics? So basically, do higher scores in mathematics correlate with females going into computer programming? Okay, so there's also another type of, or two other types of categorizations of data. One is categorical, which places an individual into one of several groups or categories, so things like gender, hair color, eye color. So it's something we could categorize. So if I'm collecting data on the shirt color of people in a classroom, that would be categorical. Quantitative data, think quantity, those are going to be numerical values like test scores, age, grade point average. Those are going to be things we can actually, take like a, find the mean of or find the median of, whereas with categorical, it's more like a category. So let's look at a couple examples here. Classify the following as either categorical or quantitative data. So marital status, that's going to be, married, single, divorced, widowed, that type of thing. Those are going to be categorical because we're categorizing. And again, think about, can I actually take the mean of this? We can't take the mean of marriage status. A person's height. Okay, well, that's going to be a number, so that's going to be quantitative. Again, we could find the mean height of people in, a building. Hair color, that's going to be categorical. We might categorize a group of people. Oops, if I can type it correctly. We might categorize a group of people based on the color of their hair: brown, blonde, gray. Number of children in a family, that is going to be quantitative. Okay, because think about it, we could say the average number of people in a family is 4. So we could run some statistics on it, like mean, median, mode, that type of thing. All right, now that we've talked about the different classifications of data, let's look at measures of central tendency. These are going to be familiar to you. We talked about these in 6th grade and in 7th grade. There's a couple things I want to point out, but for the most part, I think you guys already know this pretty well. So measures of central tendency are used to generalize data sets and identify common values. First one we're really familiar with is the mean, and it is the average of a numerical data set. Something that might be a little new to you will be this symbol, this symbol right here. It looks like an X with a little bar above it. We actually call it X bar. X bar is the symbol that we use to denote the mean of a data set. So instead of writing like mean equals blank, we would write X bar equals blank. To calculate mean, just quick reminder because you guys know this, just add up the data values and divide by the number of data values. The mean is especially useful when your data values don't have a great variation. We don't want to have any outliers in our data set, and we want our distribution of our data set to be fairly symmetric. Another one that's probably familiar to you is the median. Median is the middle number when the values are written in numerical order, so they have to be in order least to greatest. That's probably one of the biggest mistakes I see, is forgetting to put the data in order before you find the median. Once you have your data in order, you're going to find the middle number. Okay, median, think middle. If your data set has an odd amount of data points, then your median will be the number that falls directly in the middle. So if there's like 7 data points, there's going to be a number directly in the middle, and that would be your median. But if you have an even set of data points, if you have 10 data points, there's not going to be a number directly in the middle, and in that case, your median is going to be the average of the 2 middle numbers. So basically, it's the middle of the 2 middle numbers. If you're not sure what it is, you can take the average by adding those 2 numbers together and dividing by 2. Median's going to be more useful when the distribution is skewed, or if there's an outlier. You're going to prefer the median over the mean when either of these things is true. First and third quartiles, those should also be familiar to you. Basically, your first quartile is the median of the lower half of your data, and the third quartile is the median of the upper half of the data. So again, you have to have your numbers in order from least to greatest, find the median, or where the median would be, and then look at the lower half of the data and find the middle of that, and the upper half of the data and find the middle of that. Mode is another one you guys are familiar with. It is the value that occurs most frequently. You can have no mode, you can have one mode, or you can have multiple modes. So if there are no numbers that repeat, then you have no mode. If only, you can have multiple numbers repeating, but if there's one number that repeats more than the others, then you only have one mode, and it's whatever that number is. If you have several numbers that repeat, just be careful. They have to repeat the same amount of time. So if I have a data set and there are 5 2s in that data set, and then there are 4 3s, they're not both modes. The 2 would be the mode because it occurs more than the 3. But if I have a data set where I have 5 2s and 5 3s, and there are no other numbers that occur that many times, then those would both be the mode. And your mode is especially useful for categorical data. So like if we're looking at hair color, I might want to know which hair color occurs the most. So it's even more useful when we're talking about categorical data. Measures of spread, most of these are pretty familiar to you as well. So measures of spread describe the diversity of the values in a data set. Measures of spread are used to help explain whether data values are very similar or very different. So the first one, which should be familiar, is range. And range is just the difference between the greatest and least values in the set. So you take your biggest number and you subtract your smallest number, and it just tells you how far apart they are. For interquartile range, which you guys also should be familiar with, you are going to need your first and third quartiles, which we talked about above. Once you've figured out what your Q3 and your Q1 are, you're just subtracting those. So it really is like the range, but interquartile. So basically that tells you the distance between the middle 50% of your data. Okay, another measure of spread that you may or may not be familiar with, I think most of you probably are, is mean absolute deviation, or sometimes we abbreviate it to just MAD. And it is the average absolute value of the difference between each data point and the mean. It essentially takes the average distance of the data points from the mean. So basically what we're doing is we're looking at how far each data point falls from the mean of the data, and then we're averaging those distances together. So a data set with a smaller mean absolute deviation has data values that are closer to the mean than a data set with a great mean absolute deviation. The greater the mean absolute deviation, the more the data is spread out. All right. The formula for mean absolute deviation is probably something you haven't seen before, and it looks pretty complex. I'm going to try and walk you through it because it really is just telling you what steps to do to figure out your MAD. So your first step in finding your MAD is to find the mean of the set of numbers, and that's what this means. Remember we talked earlier about X bar? So the first thing you have to do is find your mean because you need it for your calculations. That's what that X bar is. Once you've found your mean, you're going to take each of your data points and subtract the mean from that from each data point. And that's what it's telling you to do right here. It's saying take each X value and subtract the mean from it. Now, we don't want negatives, so we take the absolute value, because really what we're trying to find is the distance, and distance is not negative. We're trying to figure out how far away is each data point from the mean. So once you subtract the mean from each data point, you want to take the absolute value. So you should have this new set of data where basically a new set of data that is the distance of each number from the mean. And what you're going to do with that new set of data is you are going to find the mean of it. So you're going to add them all together and you're going to divide by how many numbers there are. And that's what it's telling you to do here. This big E looking symbol is what we call a sigma. And in math, the sigma symbol means that you're going to be adding a set of numbers together. So in this case, the set of numbers that we're adding are those distances we found. And then it's telling us to take that sum and divide it by n, which is the number of data values.